Hello everyone, this is Lokesh here. In this video, we'll learn about Python decorators. I'm going to divide this video into two parts. In the first part, we'll learn about basics, how to write a decorator, and few examples. In the second video, we'll continue with few more examples and how to write a decorator with arguments and few more examples on decorator with arguments. So let's go into the video. So what is a decorator? The formal definition of decorator is a function which takes another function, modifies its original behavior, and then return another function. Okay, but why do we need to modify a function's behavior? Okay, consider this case. We have a HTTP handler here. It's a function which takes request and returns a response. Fine. So assume that we have a large code base and we have hundreds of HTTP handlers like this, and we want to inject some common code into each of these HTTP handlers. So when we add the same lines of code into each of these HTTP handlers, our code base looks duplicated. So how can we solve this problem? So we can solve this by creating one function and then call that function each of these HTTP handlers. So like this, do some stuff here with request and do something with response here. So then we'll end up copy pasting the same functions in each of the HTTP handlers. So when we use decorator, we will be placing these two functions in a common function, which is decorator, and we will just decorate this function with the decorator. Now let me give an analogy from mathematics. As we see here, we have f of x and g of x. Here we are substituting g of x into f of x such that it will become f of x plus 5. That means in place of x, substitute x plus 5, and it will become 3x plus 17. Similarly, we can do it in programming too. We can pass a function as an argument to another function, and we can assign a function to variables and so on. In Python, functions are first-class citizens. That means you can assign them to variables and store them in data structures and pass them as arguments to other functions, and you can nest functions. That means you can write a function inside function and return function from another function. So now we will see examples for each of these points. If you are already aware of this, then you can skip this. So now let's see how can we assign a function to a variable. So let me do obj equal to fetch movies by actor, and let me print obj. Right. So here I assigned this function to a variable. When I printed it, I got fetch movies by actor at it's a function at memory location. So let me also print fetch movies by actor. So as we see here, the memory address locations of these two are same. That means when we assign a function to a variable, what happens is a new variable will be created which will point to the same memory location. So now we'll see how can we store functions in data structures. So here I have a variable called list of movies, and then here I'm trying to store the function for 5 times in a list like this. So let me print list of movies. Right, so as we see here, we have 5 functions and then they are in a list. So that means we can store functions just like any other primitive type in lists or in dictionaries, sets, whatever. So now we'll see how can we pass a function as argument to other functions. Here we see there's a function fetch movie details which can take a function and then calls that function and returns the result. So here let me pass fetch movies by actor to this function. That means I'm passing a function as an argument to another function. So let me print the result. Right, I got the result. And now we'll see how can we nest functions. That means function inside a function. So as we see here, there's a function called fetch movie genres by year, and inside we have another function and we are calling that function here. So here one interesting thing that we can look here is here if you see this filtered movies is a outer scoped variable, that means which belongs to the main function, but we are able to access that variable inside the nested function. So this is called closure. So this closure is a big concept. I'll make a separate video on this. So for now we will just learn this is a closure. We can access outer scoped variables inside the nested function. Okay, so let me run this function and I got the result. So now we will take a look at how can we return functions from functions. So here I have the same function, but I modified it a little bit. Instead of calling this function, the nested function here, instead I'm returning this function. So that means let me call this again. So earlier we got the journal directly, but here we are getting the function. So that actual function. So let me assign this to a variable, and then we need to call that. So we'll get generates by movie name function, and now we need to call this guy with a movie name. Oh, okay, so why is this okay, I think so it says index error. I think something wrong we have done. So we have given 1994, but 1994 there is but we have given Django Unchained, but Django Unchained released in 2012. So that's why there is index error. So that means here we need to give 2012. No, probably. So this is right. We'll keep this. We'll give this Shashank Redemption. Right, now we got it. You might be wondering why we learned about function properties instead of implementing decorator directly. Because these are basic concepts that we will apply in writing decorator. So here we already learned about passing function as argument, and we learned about nesting functions and then returning functions of functions. Now we will try to apply these concepts and see how to write a decorator. As we already learned from the formal definition of decorator, decorator is a function which takes a function as argument and modifies its original behavior and then returns another function. So here we have a function, the original function, which is denoted in blue, and we have decorator denoted in red. So what does this usually means? So this means that decorator is a function and takes this function, as we see this blue color, this function, and then modifies its original behavior. That means modifies the original function's behavior and returns another func. So here we need to create another func, right, which will modify the original behavior of this original function and then returns this another func here. So here you might be wondering where are the star args and star k args in the decorator function. So we need to think where to put these star args and star k args, whether we have to put in the decorator function here or in the another function. That we will see now. So we will derive that. So from here we know that func will become decorator of func, right? So let's call this step 1. So when we want to call this func with args and k args, so from the step 1 we know that func equal to this one, right? So that means let's substitute this decorator of func in place of func here. So that is decorator of func and star args and star k args. So from above definition we know that so this decorator of function returns another func, right? So that means we can substitute in place of this decorator of func, we can substitute another func here. So that means we will be ending up passing these args and k args to another func, right? So that means these args and k args should go to another func. So we will place them here. Now we will jump into coding and try to implement decorator. So let's write the code what we have written here. So we'll first write decorator which takes original function, let's say func, and here we need to return another func. Instead, let's say inner. That means inner function. So we'll do inner, and we already learned that the original function's arguments will go to inner. This. So this is the basic decorator. I mean the skeleton of decorator, right? So let me do one thing. So here let me add some print statements. Entered decorator, something like this, right? So now let me take one function, sorry, add a comma b, return a plus b. So we'll add syntactic notation decorator. So now let me call add with 1 comma 2, right? So now we see here whatever we added, the print statement, we can see that here, right? Enter decorator. So let's do one thing, let me print actually. So now we see enter decorator and none. So because when we used the actual decorator, that means we are about to change the behavior of the function, right? So the actual behavior of the function is it returns an integer, which will be the sum of a and b. But here when we change the behavior of the function, we are not returning anything here, right? So inside inner we are not returning anything, we are returning none. So that's why it printed none. So that means we have changed the behavior of original function. So now instead of returning none, let me try to return the actual result. So I mean I don't want to change the return type of the original function. So instead what I'll do is result equal to func of star args comma star star kx. So here what I'm doing is I'm actually calling the original function with its original arguments, so that I'll get the actual result. And let me do return result. So now let me call this here. Now print add of 1 comma 2. So now we see enter decorator and return 3. So that means we have retained the return type of the original function. So now we will look at few examples using decorators. So here I want to create a decorator called exception logger. Exception logger is a decorator which catches and logs all the exceptions. So this example is one of my work experiences. This is my practical experience where we have very big code base, and in each of the function we want to try and catch all the exceptions and then log those exceptions. Then at one time we felt that we were actually writing the same try and except blocks, and the code looks duplicated. And then we created a decorator called exception logger, which catches all the exceptions and logs it. So the first things first, we know the basic skeleton of the decorator. So we will say exception logger. So this is the decorator name, which takes the actual function and it returns another function. So let me create that another function, and the inner function takes the original function's arguments like this. So the basic skeleton is ready. So now we need to write the actual logic. So the logic is simple. So we want to try and catch all the exceptions and then logs it. So let me import logging. Let me create a logger here. Right here, let me do try result equal to func of and let me catch all the exceptions. So let's catch the broad exception clause, and here let me log that some exception occurred. So here we are calling the original function, and when this original function is being executed, there can be exceptions occur, right? So here that's why we are catching all those exceptions and logging them, and we are suppressing them. That means we are not raising anything, so we're just suppressing those exceptions, right? This is okay. So here we might want to add some more information. So some exception occurred while calling the function with what are the args and what are the keyword args. So let me add them. So the function is when we do func dot underscore name underscore, it will give the function's name and args, right? So now let me try to use this decorator. So to use this, let me create another function which is division a comma b, return a by b, and let me use exception logger here. And here let me call division with 1 comma 0. So that means when I do 1 by 0, it will give 0 division error. So let's see whether that exception is logging or not. So let me run this guy. Right. So as we see here, some exception occurred while calling division with args and k-args, and this is not the actual exception. This is the log. When we use logger.exception, it will automatically logs the exception trace. And here it is none. Oh yeah. So as we see earlier, we need to return result, right? Or else we will be ending up with changing the written type of the original function. No, we should not change the written type of original function. So that's why remember we should always return the result. So we are returning the result. So let me try the positive case. So let's say 4 comma 2, and now let me comment this and let me run this guy. Yeah, it's 2, so which is expected. Let's look at another example. So this time I want to write a decorator called timeit. It is a decorator which logs the total time a function has taken. So yeah, the first things first, we will write the skeleton timeit, and we will return inner, and inner takes the original function's arguments. So this is the inner. Generally, what I recommend people is that you first write skeleton and then think about the logic. So here we will call the original function and we will return the result. Yeah, this will do, but as we want to measure the total time before calling the function, we will note down the timestamp. So let's say start time equal to time dot time. I think I need to import time module, and after calling the function, we will log the same. Right now we will log the number of seconds. So total time taken by function is seconds. So here we'll say func dot underscore name, right? And int of n time minus start time, right? So let's try to use this. So in order to use this decorator, we need to have a function. So let me create a function called print numbers, which will take n. For I in range of n, it just prints that. Okay. So let me use this timeit decorator here. and let me print first 1000 numbers and see how much time it is taking. Let me run this program. Right. So the total time taken by function. Oh, I think we missed. Oh, right. So in. Oh, I think I forgot to put percentile here. Okay. So let me run again. Yeah, total time taken by function print numbers is 0 seconds. Okay, sorry. I shouldn't have put n int because it is converting that to the round integer. Yeah. So here we got 0.10 seconds. Now let me test this timeit function in a different way. So before printing the actual number, let's sleep for maybe for a second, right? And here let's give 10, and let me try to run this guy. Yeah, so as we see here, uh, I mean it's pausing for a second and then printing, and if we see the total time, it is 10.03, right? It is correct. So total 10 seconds and 0.03. Yeah, total 10.03, so which is right. That's it for this video, guys. In the next video, we will see decorator with arguments and a few more real world examples. Thanks for watching. If you liked the video, please like, subscribe and share it with your friends and colleagues.